let's start it. In this session, we are going to start Master AWS Glue. So, as a part of Master AWS Glue, let's start understanding uh, what is AWS Glue. What is AWS Glue? AWS Glue is a fully managed ETL service. So, first, let's understand what is ETL. ETL stands for extract, transform, and load the data. AWS Glue can be used to connect different sources. Different sources. Let's say, let's say S3. S3. Let's say extracting data from S3, then applying transformation. Let's say this is my sales data. Sales data is presented in my S3 location. Then I want to filter records. I want to filter records based on city. I want to filter the records based on city. Then I can write a transformation, filter transformation. From extracted data, we can apply transformation. This transformed data we can collect and we can load into either again into S3 or data warehouses like Redshift, Redshift, or data warehouses like Snowflake, etc. So whatever target, whatever input, whatever target, whatever target. So extract the data from different sources, apply the transformations, transform data you can load into any target. So this kind of implementation we can achieve using AWS Cloud. AWS Cloud, AWS Glue. AWS Glue is a cloud-based. It means you no need to install and configure. Same thing we can achieve using PySpark, but PySpark we need to set up a cluster. We need to set up a cluster. AWS Glue is a serverless architecture. It is fully managed ETL tool for data processing, data processing and data analytics. It is serverless team. What is serverless? Assume, assume ETL process purpose, ETL process purpose. Let's say I used PySpark. I used PySpark for ETL processing purpose. Let's say I developed this PySpark application in my developer mission. I developed this application where we want to deploy. Let's say we are taking different EC2 missions and we are setuping and we are configuring. Assume we set up we set up 200 missions, 200 missions PySpark cluster. So we take EC2 missions, we install required software, then we create a configuration for master workers like that. Yes or no? So here we have to do lot of manual activity for installation and configuration and management purpose. Coming to AWS Glue, it is pure serverless. Serverless. No need to manage infrastructure. No need to create infrastructure like this. No need. AWS Glue automatically provisions resources as needed. As needed. Let me explain. Let me explain. This is my source. Source. Let's say source is S3. In this S3, there is a bucket. In the bucket, We have sales file, sales file. Let's say sales file, sales file. This sales file contain data. Let's say this data is 1 GB data, 1 GB data. You are using AWS Glue, AWS Glue to process this data, AWS Glue to process this data. You developed ETL application. You developed ETL application for taking this data and writing the data output into, let's say, Redshift. Redshift. So through this ETL application, final you are running this one. So for this, where you are running inside AWS Glue environment. Let's say you submitted this application. For this application, only one mission is enough. No need of multiple missions. If it is PySpark cluster, whether we required or not, we set up a cluster with 200 missions. But 200 missions are not required to process 1 GB data. Yes or no? You need to set up. But here it is serverless architecture. No need to manage infrastructure. The resource it created, it contained Spark software, Glue software inside it. Dynamically, it creates a resource and deploys your application and runs your application in this machine. Once the processing is completed, it will release these resources. Let's say I'm using, let's say sales data is 10 GB. To process 10 GB data, we need 4 missions. It will create 4 missions and runs this 1 GB data. Once execution is completed, it releases 4 missions. Let's say I am passing 1 TB data. Assume to process 1 TB data, we need 50 missions. 50 missions automatically creates, process your 1 TB data. Once execution is completed, it will release resources called serverless. Yeah, okay. So AWS Glue is a serverless. Dynamically, it will allocate resources. Once execution is completed, it releases resources. So it is cost effective. Cost effective. Let's say if you set up a physical cluster with 200 nodes, whether your input may be 1 GB or 10 GB, you have to manage this entire cluster. You have to purchase this hardware. You have to manage this entire cluster. Let's say your work is only less than a minute, and after minute, again you may get requirement after some time. Then you have to manage this cluster. But Glue creates a resource, execute your ETL job. Once execution is completed, it releases this resource. Let's say assume this resource used less than 1 minute and used 16 GB RAM, 16 GB RAM, then used 8 core processor. For 1 minute, they will calculate the pricing, they will charge for you. So it is cost effective. How, how many resources you used? How many resources used for your job? How many missions used for your job? How much time they ran? Based on that, they are going to charge. So we have to care while working with serverless architecture. And while setting this AWS Glue, we can provide I want a minimum of 2 missions, maximum of 200 missions. Within that range, it will create resources based on your input data. Okay, let's understand key features of AWS Glue. First important key feature is AWS Glue Data Catalog. AWS Glue Data Catalog. This is AWS Glue Data Catalog. AWS Glue Data Catalog. In this AWS Glue Data Catalog, we will store meta information of your input data. Metadata of your input data. Let's say your input is S3. Your input is S3. And S3 we have files. We have files. Each file information we can persist as a meta information like file name, file location, and file contained how many columns and what is the column data type. That meta information we can persist into AWS Glue Data Catalog. What is the advantage of persisting this metadata information into Glue Data Catalog? Initially, it is developed for Glue applications. Let's say I am writing ETL application, ETL application. Okay, I am writing ETL application using Glue technology. Glue technology. I am reading S3 file. Instead of writing that metadata reading logic from this file, I can get this metadata from this Glue data catalog. Then I can continue reading and processing of this file. Instead of defining schema logic inside my ETL job, I can get that meta information from Glue data catalog. Then I can proceed reading and processing logic. I focus on this one instead of spending defining schema logic inside my ETL job. Initially, this was developed for Glue job implementation. Because of this Glue advantage, multiple services like Athena also wants to read this file. So they can also access this metadata, then read that data based on this metadata information. Like this, multiple services using this metadata information. That's why they made it as a central repo to multiple services. They are treating, not maintaining, they are treating this AWS Glue data catalog as a central repository for multiple services. If they want to read this read file, instead of developing schema definition in their technology, they are connecting to getting that meta information and processing. So one important key feature is AWS Glue data catalog. Next one. Automatic schema discovery. Automatic schema discovery. This is my input file. S3. S3. Okay. Here we have a bucket. Here we have a file called sales. Sales. So sales file, initially we have 10 columns. 10 columns. Let's say today it has a 10 columns. We created the definition in our Glue data catalog. Okay, we are writing ETL application. We are processing this one. And new file they loaded, they added one more column or two more columns. Then here it will detect this definition. Let's say automatic schema discovery feature. Automatic schema discovery feature. We can enable this automatic schema discovery. If any change in our input data, we can update that schema information in our glue data catalog so that our ETL job never fail. Sorry, our ETL job never fail. Our, let's say, Athena, we are writing analytic queries. These analytic queries never fail. Let's say based on the timestamp, today we have different timestamp, tomorrow different timestamp. If timestamp changed, it go input location, checks is there any schema change. If any schema change, it update that schema information into metastore. Next one thing, it has a ETL engine. ETL engine. What is the purpose of this ETL engine? Let's say, let's say, tip, let's understand key important feature of ETL engine. In Glue, AWS Glue, it is providing drag and drop, drag and drop feature, drag and drop feature. So source, source and transformation, transformation and target. Let's say source is S3 and S3 file location, S3 file location path and transformation, let's say filter and target, let's say redshift, redshift. You have a feature of drag and drop, then modify properties means S3 path location, filter condition and target properties. Just to change the properties, then ETL engine will taken care to convert this code either Python programming format or Scala format. Scala format default is a Python format called, it will generate a PySpark code. It will generate a PySpark code. If you choose Scala language, it will generate a Spark and Scala. Spark and Scala. So you can choose a language of code generation of your AWS Glue ETL job. By default is Python. So it will generate code, PySpark code. Once a code is generated, once a code is generated, you can do modification. You can edit the code if you not like it. If you add new code or if you want to add some additional feature to a generated code, you can do. Or you can, AWS Glue provides, AWS Glue provides one drag and drop drag and drop called graphical approach. Drag and drop called graphical approach. Second one, if you want to write direct code, then it provides programmatic approach. You can write PySpark with Glue API. You can write code manually. This generated code also we can edit if you not like it. If you satisfy, you can use it. If you not like it, you can edit. If you want to add more features, you can edit and add new features to generated code. And next important feature is job scheduling. You no need to depend on different scheduling tools like step functions, like Airflow. You no need to depend upon uh, different tools for scheduling Glue jobs. Glue itself contain a job scheduling feature. You can define your scheduling using Glue, but it works only for Glue jobs. That said, yes, that's what I'm saying. This scheduling works only for Glue jobs. Let's say I want to schedule uh, Athena jobs. I want to schedule uh, Lambda jobs. I want to schedule Kinesis jobs. Then it will not work. It will work only for Glue jobs. If you want other AWS services jobs also, I want to orchestrate or define data pipeline. Then AWS having a feature separate service called AWS step functions. For any AWS service, you can define data pipeline or orchestration using AWS step functions. Along with AWS, I want to define not only AWS, I want to define anything. Then we have multiple tools. There is one powerful software is Apache Airflow. So if you are working only Glue jobs, you no need other scheduling tool. You can use this job scheduling feature. Along with Glue, you are using multiple other services. Go with step functions. Your project contain only AWS services. Then go preferred one is AWS step functions. Along with AWS services, you may have other technologies outside of AWS. Then recommended one is multiple other data orchestration tools like Apache Airflow. So AWS Glue itself contain a scheduling feature. And next one thing, data ingestion. You can use AWS Glue. You can connect with the different sources. You can ingest data into these services. You can ingest data. I do not want any transformation. Just I want to move data from S3 to Redshift to S3. No need of writing complex logic. Uh, or no need to manually write. You can just to drag source. You can just to try target, and transformation is just data movement logic. That's it. It will generate a ETL code for your data ingestion. Then you can use that code, you can run. You can move from one source to other source. Next one, scalability team. So we understand it is a serverless. It is a serverless. Yes, scalability team. Here, let me open AWS Glue service team. Let me open AWS Glue service. Here, we can create ETL job. Let's say ETL job. Here, there is a job details. Here, you can see here worker type, worker type. Here, we can provide how many workers you want. You can provide how many workers you want. Based on this, it will scale your cluster. Let's say minimum I want to 2 machines, maximum 100 machines. Your data is 1 GB. Then it creates only 2 machines. Your data is 10 GB. It will create, based on data size, it will create more machines. Scales automatically. No need of a physical cluster. It will create resources based on your data load, and once the processing is completed, it will release resources called dynamically scaling resources based on the workload. And security and monitoring team. Security and monitoring. By default, we get security from IAM. See, in Java, we have IAM role. Let's say I am developing Gluja, this Gluja. Let's say job one, sorry, job one dot py. Here I'm writing glue ETL job. I'm writing glue ETL job. This job want to access S3. S3. This glue job wants to write output into Redshift, Redshift or other service. Then we create a role. We create a role. For this role, we give read of S3, write of Redshift. Then we assign that role here. We assign that role here so that a glue can communicate with these services. By default, a service cannot have permission to access other service. A service cannot have access to other service. So first level security we can achieve using IAM role. Next one. Let's let's say we are 20 members. For all 20 members, I do not give AWS Glue access. Then we can achieve by using AWS IAM while assigning permission to user. I cannot give AWS Glue access for some users so that they cannot access AWS Glue. Such kind of securities we can get using AWS IAM. Next one, team. We return ETL job. I want to know what is happen once processing. It may fail, it may success. I can configure CloudWatch to my ETL job so that I can go and watch AWS CloudWatch about this ETL job. Okay, so we can have a security and monitoring in this AWS Glue. You no need a separate configuration. By default, A cloud watch attached to your ETL job, you can go, you can verify logs. Okay. Yeah. Any question up to now? Yeah. Now let's understand. We understand what is AWS Glue. We understand key features of AWS Glue. Now let's understand why use AWS Glue. First one, if you use PySpark, you need to do lot of manual coding and you need to deploy debugging purpose, lot of activities you have to do. So it reduces ETL development time by providing drag and drop feature and it will generate a code. Later you can edit if not satisfy some parts. So it will reduce a lot of manual efforts. Next one, simplifies data management. So we can use AWS Glue to unify data from multiple sources into a single searchable catalog. I have different sources, source 1, source 2, source 3, source 4. For all these sources, you can create a metadata in metadata in a single location. Then from my application, it is easy to search, right? Instead of going and connecting different sources, reading and writing this logic, this is very easy. We can easily get all that sources information in single meta location, right? And next one, Glue supports multiple file formats. It supports CSV, JSON, Parquet, ORC, Avro. It supports all file formats. And I said ETL engine. You just configured source, filter, and target. And it will generate a PySpark code, I said. It will generate optimized coding. Okay. And we can integrate with different AWS services. AWS Glue can be used to integrate with different AWS services. S3, Redshift, and many other services. You no need separate mechanism. You need only access permission. So using AWS IAM, we can give, we can create a role and we can attach role to our ETL job. Let's say I want access of S3. You can give read access. I want to write access of Redshift. You can give, you can attach policy to role. Then you attach that role to glue job so that a glue can communicate with different AWS services. Okay. Yeah. Let's start understanding use cases of AWS Glue. As part of master AWS Glue, let's start understanding use cases of AWS Glue team. So AWS Glue mainly used for ETL operations team, data extraction, transformation, and loading. Using AWS Glue, we connect different sources, we extract the data, we apply transformations, and load the data into target. So source may be file system, source may be S3, source may be any data warehouse, target may be S3, target may be any data warehouse. So to perform ETL operations, we use AWS Glue. Especially to perform data warehousing and analytics. Nowadays, you are seeing these reporting tools like Power BI, Tableau, QuickSight, QuickSight, and machine learning people and artificial intelligence people. They are going to connect data warehouse. They are going to read data from data warehouse. Data warehouses like Amazon Redshift and Snowflake contain huge volumes of data sets. So instead of applying analytic operations on huge volumes of data sets, because let's say Power BI, they want to display current day data. Let's say warehouse contain last 10 years of data. Instead of waiting to process on 10 years data, they want to only, let's say, Ugadi related. Let's say coming, Christmas is coming. Let's say every Christmas last 10 years, what is happened? We want to know. So instead of sending to process 10 years data, we want only Christmas data. That kind of analytics on warehouse we can perform using AWS Glue. Then you can store the result like Christmas results only. Then our reporting tools, instead of pointing 10 years data, they point to this processed data, they can represent easily. So on data warehouse, if you want to perform any analytics, then we go with these kind of AWS Glue kind of technologies because these are distributed parallel processing, serverless computing, and it can process any volume size of data in parallel and distributed manner. Backend, it uses Spark technology. Okay. And other one, data lake management. Other important one, data lake management. My client want use S3, S3, S3. Let's say various sources, various sources. Source 1 to source n, source 1 to source n. They want to extract this data. They want to load it into raw layer, raw layer. So use glue, connect different sources, load the data into raw layer. Then, then they want to do basic analysis on raw data. They want to do basic analysis on raw data like data count and basic validations like data type checks and string formatting and uh, date column format to change, such kind of basic analysis, and they want to store it in the branch layer. On this branch layer, they want to perform some basic filter operations and they want to move it into silver layer. On this, they want to apply transformations and finally they want to store it into gold layer. These kind of data lake maintenance they want to do. Then each layer you can apply glue jobs, glue jobs, and glue job. Then you can organize in data lake. These kind of use cases also we are going to we are uh, going to use AWS Glue. And next important one, real time and batch processing. Real time and batch processing. Here, Tim, using Glue, you can implement streaming called real time and batch processing. batch processing using Glue. Using Glue, you can implement streaming and batch processing. But it is never recommended to go for the streaming using Glue. It is recommended to implement batch processing. Streaming process recommended Kinesis service. Then use Kinesis service for streaming operation. You can take streaming data using Kinesis service. Once it prepares that batch, right? On this batch data, go with batch analytics using Glue. This Kinesis Glue kind of implementation is recommended. Glue having real-time means streaming, batch processing. It is never recommended for streaming. It is recommended for batch processing. So for streaming purpose, our AWS providing powerful service called Kinesis. It is specialized only for streaming operation. So go with that Kinesis for streaming. Once it generated batch data, go with Glue for analysis purpose on batch data or batch processing. From beginning of Glue, I'm saying Glue meant for not small data. It is meant for processing huge volumes of datasets in a distributed and parallel manner. In streaming, for every second or 5 seconds or 10 seconds, we will configure. You may get small pieces of data, right? So for such kind of requirement, go with the specialized service called Kinesis. Okay, it has a streaming feature, but don't go for streaming for AWS Glue. It supports both streaming and batch processing and data ingestion across multiple sources. You can connect to different sources. Let me show AWS Glue. Let me open AWS Glue. Let me create one ETL job. I'm not going to create complete job. Just for sources, I'm going to show. Just click on Visual ETL. Okay. Let me see sources. See, these are different sources. Glue catalog, S3. You can take source from Kinesis, Apache Kafka, relational databases, Redshift, MySQL, PostgreSQL, Oracle, Microsoft SQL Server, DynamoDB, Snowflake, BigQuery, Teradata, Amazon OpenSearch, Vertica, Azure SQL, SAP HANA, Azure Cosmos, MongoDB, and Adobe Analytics. See multiple sources. Facebook ads. See, these are different sources. It's supporting various sources. So you can use AWS Glue for data ingestion purpose for connecting different sources, load the data into your target data store. It's supporting multiple sources. Next one thing. Glue also can be integrated with these monitoring alarm systems. Let's say my CloudWatch contain logs with multiple technologies. Let's say multiple jobs configured, then you can track that and monitor that, and you can apply apply processing. You can implement monitoring and alerting using AWS Glue built-in monitoring tools. Track job execution and performance. We can integrate with the CloudWatch, SNS, and different notification service. If your job, let's say you written ETL job using AWS Glue, you can integrate with the CloudWatch. You can write log into CloudWatch. You can integrate with SNS so that if job is completed, you can send a notification. And you want to schedule Glue jobs, we can use Glue service also. We have different scheduling technologies like Lambda, step functions, but you have only Glue jobs. Then you know you no need other supported technologies. Let's say you have 10 Glue jobs. Go with the scheduling with Glue only. Yeah, uh, next one, it is a serverless computing. So if you want to reduce cost compared to fixed cluster of PySpark, fixed cluster of EMR, let's say your existing applications running a fixed cluster of Spark cluster or fixed cluster of EMR, we can avoid that one. We can convert those applications into AWS Glue. You can reduce cost. You can migrate those applications with Glue, then you can reduce cost. Okay, so these kind of implementations, we go for AWS Glue team. Yeah, now let's understand very important component concept in master AWS Glue is components of AWS Glue. So main components, AWS Glue data catalog, crawler, ETL engine, and scheduling system, and Glue workflows, Glue Studio, and AWS Glue Data Brew. These are main important components of it. First, let's start understanding these components of it. First, let's start understanding AWS Glue Studio. AWS Glue Studio. Let's say this is my AWS Glue Studio. Glue Studio, It providing to develop a Glue applications using drag, and drop. Drag and drop. Let me show Glue Studio. This is my AWS Glue Studio. I can select a visual detail. Then you can select S3. You can select S3. You can select a transformation. You can select a join. Then you can select a target. Let's say target is again Redshift. Such kind of drag and drop. Then once you save this program one, then if you click on save, then you can see script. Yeah, we have to provide additional operations. Then it will generate a PySpark code. Okay. You can Glue Studio provides for for writing Glue application stream. First important one is Glue Studio. Glue Studio. Okay, once you develop, let's say, next important one, Glue Data Catalog. So it provides central repository in Glue. It provides central repository in Glue. It holds meta information of your input source. Your input source. Let's say Glue data catalog. Glue data catalog. Here, source 1 is S3. Source 1 is S3. Source 2 is MySQL. Source 3 is SAP HANA. SAP HANA. So for all sources, we are connecting and we are creating a crawler. We are creating a crawler. We are connecting these sources. We are connecting these sources. We are storing information into our location. In Glue data catalog, we are creating database. Under database, we are creating table for each source. Table 1 for source 1. Table 2 for source 2. Table 3 for source 3. This table contains metadata information. Metadata information means where your data is presented, source location and source path. Next one, column names, data types. So we will store meta information. For that storing meta information, we are going to use crawler. Crawler in AWS connects to input source and reads the data and identify column names, and it identifies data types. It identifies data types, and it stores that information into Glue data catalog. So while writing Glue application, you can connect to this data catalog. You no need to write the definition here. You can directly read these sources details here. Okay. Next one, ETL engine. Let's say you performed drag and drop. Then you clicked on save button. Once you provided all properties, this one is going to generate a PySpark script for you. It will generate a PySpark code. It will generate what? PySpark code, optimized code, ETL script. You can select a Scala language. By default, it is Python. Default language is Python. That's why it will generate PySpark code. So clear, right? This job scheduling, ETL engine purpose, crawler purpose. So what crawler is doing? It connecting input sources and storing that meta information into Glue data catalog. ETL engine, once you save job, what it is doing? It is generating a PySpark code by default. If you select a Scala language, then it will generate a Spark and Scala code. Job scheduling system can be used to schedule your ETL job. I want to define workflow. I have multiple Glue ETL jobs. I want to define a workflow. This job executes first. This job executes next. This job executes next. You have only ETL jobs, then you can define workflow using AWS Glue workflow management. If you have multiple other AWS Glue jobs like Athena, Kinesis, then go with AWS Step Functions. AWS Glue workflow only for AWS Glue jobs. And AWS Glue Data Brew for self-preparation of data. It is a self-service for data preparation tool for data cleaning and data transformation, and it provides built-in 250 transformations for formatting, deduplication, enrichment. You can easily integrate with tools like QuickSight and Tableau. So these are different important components too. Yeah, let's start understanding AWS Glue terminology too. In our Glue application development, we are going to use this terminology in all our programs. First one, classifier. Very, very important. Someone in the beginning, they asked, you may have CSV file. Inside a CSV file, you may use comma delimiter. Someone may use hash delimiter. Someone may use tab separator. Someone may use different delimiter for columns data. Yeah, here there is one important concept called classifier. AWS Glue providing built-in classifiers. CSV a separate classifier, JSON separate classifier, XML for every file format it is providing a separate classifier. So we give a source, right? Whenever you give a source for storing metadata information, we select a crawler. Let me show crawler. Uh, let's go here. We have a crawler. In crawler, we create a crawler. Create a crawler. Then here we give a X something and click on next button. Let's say here we select a input source. Let's say I am selecting file from this location. Let's say I'm selecting file from this location. See, I'm selecting CSV file. I choose it. Whenever I choose this CSV file, whenever we choose CSV file, let's select uh, this S3 demo. That's it. Whenever you select this folder, it is saying crawl all subfolders. Okay, these are all. Let's select a file. Then see here you can see custom classifier. By default, assume your CSV file in CSV standard format. Means column is a default delimiter for all columns. All columns. Then you no need this custom classifier. Let's say your file contain uh, tab space as a delimiter or pipe as a delimiter, hash as a delimiter. Click on this custom classifier. Then select add new classifier. Here we will define classifier for our file format XML, CSV, JSON. Let's say my input file is style. Then here what kind of delimiter you have. You can select all delimiters. If it is other, you can select other, mention your classifier. So here classifier, default classifier follows default file format rules. If your file contain different format, create a custom classifier, specify your delimiter type in that. Okay, next one, AWS Glue Data Catalog. AWS Glue Data Catalog stores meta information. Meta information. Where is your input file path? Second one, column name inside that file, and data type of that file. It stores that meta information. Next one, very, very important one, connection. Connection. Let's say your source is RDBMS, RDBMS, RDBMS. Your source is RDBMS. Okay. You want to read RDBMS table. Then you need JDBC connection details, right? So that JDBC connection we can create using this connection concept. Any JDBC connection creatable or readable. You can create a connection and you can read from any JDBC connectable resources using Glue. Let's say you have in other cloud, you may have RDBMS setup, or you may have your physical or on-premise database. Then you can use create a connection. You can provide connection details. You can connect to that source. You can ingest data into your target location. But you want to create a connection, you want to store meta information first. Then you use this concept called connection. Next one, database. Database. In Glue data catalog, okay, you are storing multiple projects. So for every project, we create a database. Let's say ICICI DB to store all ICICI database related, ICICI account related. Then another database, HDFC, not HDFC, HDFC only, right? HDFC underscore DB. Like this, you can create a database and that client related tables you can store. In AWS Glue, we create a database for every project. That project related sources, meta information we store. ICICI, they having 10 sources. All these 10 sources related, we are storing into this database. And HDFC having 20 sources. All these 20 sources, tables, meta information, we are storing into HDFC DB. Instead of uh, avoiding duplicateness and avoiding names segregation, names to maintain name segregations separately for every client, we create a database in AWS Glue data catalog. And very, very important one terminology is crawler. To connect with every source to get meta information, we use concept called crawler. Okay, these are very, very important terminology. Next important terminology, data store, data source, data target. First, data source. In Glue job, we just to drag source, right? That is data source. And we just to drag target, right? That is data target. Terminology is data source, data target. And data store means it's a location where your data is going to store. Okay. And next very, very important point is dynamic frame. In Spark, we discussed data frame. Yes or no? We discussed data frame. What is data frame? It is a structured format. It is a structured format. On this, we can apply the Excel queries. Yes or no? On top of Spark data frame, they developed dynamic data frame to support these AWS terminology. On data frame, AWS Glue developed dynamic data frame. It is also structured format to support AWS Glue. And finally, once you save your program, it will generate a Python code, right? That Python code, we call it as script. Once we save program, once we save that Glue ETL script, ETL job, then it will save a file in either Python or Scala. That program, we call it as script. Now let's start understanding job. This is my ETL script. This is one job. And we have another ETL script. That is another job. Every ETL script, we call it as job. We can configure that job using any orchestration tool. Inbuilt AWS Glue having scheduling plus workflow. Using step functions, we can define workflow. Using Apache Airflow, we can define workflow and scheduling. So every ETL script, we can call it as a job. And next one, table. Very, very important one, table. So what is table? A table contain input path location and column name and data type and type of that file, whether it is CSV, Parquet, etc. Okay, clear, right? So these are the terminologies we use multiple times in our Glue application development. Okay, yeah, yeah. As part of master AWS Glue, let's understand AWS Glue Data Catalog introduction. Let's say this is my AWS Glue. This is my AWS Glue. Here, first we create a database. Yes, sir. Inside a Glue, we create a database. Let's say this database is for ICI. This database is for HDFS. No, not HDFS. Bank name HDFS is a Hadoop distributed file system. HDFC, not HDFS, HDFC Bank. Let's say this database is for HDFC Bank. So these are different sources of ICICI Bank. Let's say they have S3, they have AWS RDS, they have AWS DynamoDB, etc. These are different sources. So using crawler, we can create a crawler and we can, let's say S3, we have CSV file. S3, we have a CSV file. Then we can create a crawler. It uses built-in classifier. CSV classifier, because this file following comma as a delimiter, comma as a delimiter. Let's say there is another file under S3, another file under S3. This is also CSV, but here they used hash as a delimiter. Then we can use custom classifier. In this custom classifier, we can say my input file contain hash as a delimiter. Then we can attach this to crawler. Then it reads this file and stores in a table information. Let's say my file presented in AWS RDS. You can directly connect. My file contained in Redshift. You can directly connect. My data presented in DynamoDB. You can connect. Let's say ICICI Bank, they have Oracle database, Oracle database, Oracle database. Okay, this is on-premise. Let's say Hyderabad, sorry, in Hyderabad, they have data center. You may see a, ICICI Bank tower in near to Wipro Circle in Hyderabad. Assume there they have a data center. They are managing their business details. They are storing into Assume here. Here you can create a connection. You can create a JDBC connection. You can give to crawler. In this JDBC connection, you can provide details of your database. Then this crawler using JDBC, it will connect here and stores metadata information of that table. Let's say I have SAP HANA. My ICICI Bank, storing data into SAP HANA ERP system. Then you can create a connection to SAP HANA using JDBC. You can connect. You can get that information. You can store into particular table. Clear? Yeah. Yeah. Let's start in. As part of master AWS Glue, let's start discussing practical example. In this practical example, we are going to see how to create a database table in AWS Glue data catalog using AWS Glue crawler. Okay. First, we are going to create a AWS S3 bucket. Then we are going to create a folder inside a bucket. Then we are going to upload a file into AWS S3 bucket first. And then later we are going to create a database. Let's say database name Akkem Sreenivas underscore DB. You can create any name. Okay, I'm going to create a database. Then I'm going to create a IAM role to access S3 bucket, and I'm going to attach this IAM role to crawler. While creating crawler, we can use option to create IAM role, or you can create IAM role first, then you can assign policy to IAM role, then you can attach IAM role to crawler. And once crawler is created to point S3 bucket, then we will run crawler. Then it is going to create a table inside this database. Okay. Let's see practically. So open any web browser. I am opening Google Chrome and log in AWS Cloud account. I already logged into my account. Okay. So navigate S3. So here in recently visited, I am seeing S3. In your case, you may not. If you already visited, you are going to see. Otherwise, you can search in search bar. You can open S3 in new tab. Okay, I am going to create a bucket here. So there are multiple buckets. Okay, but I'm creating a separate bucket for us. So create a bucket. Bucket name I'm creating Akkem Sreenivas underscore blue. Okay, and give a public access. Then click on I acknowledge. Then click on create a bucket. Okay, this name already existed. So Akkem underscore Sreenivas underscore blue underscore sorry Akkem underscore Sreenivas underscore glue. Let me create this one. This is also, yeah, first one. This bucket name contains invalid characters. So here we have to give hyphen t, not underscore. Bucket name, we have to give hyphen. Let's create this one. Create a bucket. Bucket is creating. Bucket is created. Akkem Sreenivas hyphen glue. Okay. Now, under this, I want to place file. So file I want to place is employee file. Let's say I am creating one folder. Folder name is employees. Create employees folder. Then in this folder, upload a file. So for all my glue practice, what I did is I see under C drive data sets. In this, you can see glue. In this, you can see glue. Here I have different files. I am going to upload this employees file. Okay, let me load this employee file. So go to S3. Here you can click on upload or you can just drag this file. You can just go to employees folder, go to here, just drag this file and click on upload. File is uploaded successfully. Okay, then this first step was completed successfully. Now create a database. Create a database. So to create this database in AWS Glue Data Catalog, open a service called Glue. Open this service in new tab. New tab. Okay. This is AWS Glue dashboard. In this AWS Glue data dashboard, you can see data catalog. Expand this one. In this data catalog, you can see databases. Okay. Here you have option of add database. Database name I'm giving Akkem Sreenivasa underscore DB. Database name you can use underscore also possible. Then I am creating a database. Okay. So database is created. Now click on this database. There are no tables, zero tables. Once we create a crawler to point to that input file location, that crawler going to read that file and identifies column names, identifies the data types, and creates a table in this location and stores that meta information. Where is input file location and what is the format of that input file? And then It stores column names. It stores data types. Based on the sample data, it will read, crawler going to read sample data, identifies the data types, and stores that data types information into this table. Okay. So how we can create a crawler? This step 2 also completed. Now step 3 and step 4, I am doing in a single step, creating IAM role and creating table using crawler. These step 3 and step 4 I am doing in a single step. Let me go to AWS Glue dashboard. Left side under data catalog, you can see crawlers. Click on crawlers. Click on create crawler. Then give a crawler name. Let's say crawler name I'm giving employees underscore crawler. Okay. Then description is optional. I'm entering same name. Then click on next button. Here we have to select the source location. Click on add data source. Our source is S3, right? Crawler supporting multiple sources stream. So I'm selecting S3 source and here S3 path. Click on browse. Okay. Our file location is Akkem Sreenivas underscore glue. And in this, select folder path, not file location. Select a folder path, then place cursor here, that red mark gone. Click on add S3 data source. Let me Yeah, crawler responsible to read S3 file location as well as it will read a file and it reads content of file, identifies column names and identifies data types and stores that meta information into table. Yeah, yes. It contains internal features to do these all activities. Yeah, one more important to note, Tim. One more important to note. Custom classifier is optional. Let me add here one important point to them. So we selected CSV file format. Yes or no? In usually CSV follows what file, what format team? What is full form of CSV? Comma separated value. It means column names separated with column, value row, each value separated with comma, right? Second point is first row is header. So these are common rules of CSV, right? So, here this custom classifier is optional because here it uses same format. Default default classifier reads CSV file and identifies the first row as a header row. Next, remaining rows as value rows. Next one, each column separated with comma. Assume your CSV file column separated with different delimiter, maybe hash, maybe dollar, maybe something, tab space. Then we are going to create a custom classifier. We are going to specify what is the delimiter of your file. So if your file not following default features, if your file contain additional changes, we use this one. Later we are going to see because my CSV file. Let me open my CSV file. It is presented under C drive, under datasets. under AWS Glue. This is my file. This file, first row is header row and the columns are separated with comma. That's why I selected default delimiter 1. Okay, next one. Click on next button and here we have to select IAM role. Third step and fourth step we are doing here. So here you can choose existed role or you can have a create a new IAM role. Here I'm creating IAM role. AWS Glue service role. I'm creating role is let's say Glue or give a name to AWS Glue service role. I'm giving uh, Akkem Sreenivas Glue. You can give any name. Usually we give valid name uh, based on the project we are working. We give corresponding name. Let's say ICICI loan module. We give like that. Let's create a role. Then now select a IAM role. Select a IAM role. Now go to IAM service. Go to IAM service. Go to IAM service. In this IAM, go to roles. What is our role name? AWS Glue service role Akkem Sreenivas Glue. Click on this role. Using crawler, what we are doing? We are connecting S3, right? We are reading, right? Then add a permission. Attach a policy. Which policy required? S3. Full access. Select this one. Click on add permission. Now I now our glue crawler having a capability to perform any activity on S3. Now click on next button. Here select a database. Once it read file, once it finds complete metadata information, it is going to create a table, right? Where you want to create the table, select a database. I'm selecting databases Akkem Sreenivasa DB. Then click on next button. Then click on create crawler. That's it. So third step, fourth step was completed. Now let's run crawler. Go to crawlers. So here click on run crawler. Then go to crawlers. Refresh this one. You can see employees crawler is running. Once this one is completed, we can see table. We can see metadata information about that table file location. Let's wait few seconds to complete this crawler running. Yeah, now you can see crawler succeeded successfully. Go to databases, click on this database. You can see employees. See database name and file location. File location and classifier is CSV. And you can click on this table. You can see column names, employee ID, employee name, is, department, and salary. Same column names, right? And data types. Yeah, yeah. Based on the sample data, it identified data types. If you're not satisfied this data types and anything, you can click on edit schema. You can modify the corresponding data types. If you're not satisfied, we have an option of edit. Clear writing, how to create a database table in AWS Glue data catalog using AWS Glue crawler. Yeah, let's continue AWS Glue. In this, let's continue building a first Glue ETL job. In this ETL job, we are going to read only specific columns. I do not want all columns. I want specific columns from S3. Fine. So for that, we are writing uh, first Glue application. Let's see here. Go to AWS Glue. Go to AWS Glue and go to AWS Glue dashboard. Here you can see ETL jobs. Here you can see Visual ETL. So here, click on Visual ETL. First, give a job name. Give a job name. You can give .py and it is optional. You can just give any name, valid name. .py is optional. Okay. Next one. Go to job details. Here we need to attach IAM role because through the job we are going to read file. We need a read access. So IAM role, select IAM role. We created a IAM role just now. AWS Glue service role -Akkem Sreenivas -Glue. Select this role. Then click on save. Okay. Now go to visual. What is our requirement? We want to read S3 file. From that S3 file, we want to read few columns. Few columns. I do not want all columns. Okay. Click on this first symbol, first source. You can directly give S3 location. Already we have a metadata in Glue data catalog. Click on this Glue data catalog. Go to this Glue data catalog. Where is your file? Select a database. In that database, what is your table name? Employees. Okay, source we selected successfully. We selected successfully. We modified all the properties. Now, go to plus symbol, transformation. In this transformation, we want to select a few fields, not all fields. We want to select a corresponding transformation. Let me see different transformations list. In this, we have select fields transformation. Click on select fields. Once you click on this select field, click on this select field. Okay, name you can give any name. Okay, here what are columns I want? My downstream is expecting employee ID, employee name, salary. So employee ID, employee name, and salary. Okay, now click on plus symbol and target. Click on target and where you want to place this data. Again, target also by S3 location. Select S3 where you want to store this data. So go to S3 location Under this glue, Akkem Sreenivas glue, I want to create a folder. Folder name is output, output. Okay. Under output, I want to store the data. So go to this glue crawler, sorry, glue crawler, select the file, select the target, and here see the format. So S3, and here file format, output, what format you are expecting. Usually output format we store in the Parquet format. Let's say this time I'm choosing output is JSON format. Then select the target location, click on browse, click on browse. In this, let's say Akkem Sreenivasa, uh, glue. In this output, go to here. Under output, here create one more folder. Let's say employees, employees, employees output. Then go to my visual ETL, click on output. Here select this folder, click on choose. Then finally click on save button. Okay. Then you can see script location. It is generated. It is generated by Spark code for you. You did complete graphical representation, dragging source, dragging filter, dragging target. We modified corresponding changes parameters or properties. Then it is generated by Spark code. Go to job details. See here language, language, default language is Python. Because of this, it is generated by Spark code. If you choose language Scala, it will generate Spark and Scala code. Other than that, nothing. You do visual, then go to job, whatever the language you want, select the language. I want a Python 3. Then click on save. Then you can go here, you can see script file in that format. Okay, we have successfully created a job. Click on run button. Click on run button. Yeah, go to runs. Then job is started. You can see job is running. Let's wait a few seconds. And if you see status is success, then your job is success. If anything failed, you can see logs. You can see the log information if it is failed. Later, if any job is failed, we are going to see logs. We are going to find the corresponding error message here. Later, we are going to see this is simple job. Hope it is success. It is succeeded. Now go to output location and verify job output. Go to S3 in this output location. In this output under employees, you can see JSON format. Click on this file and download this file. Go to this file location and open this file. So we are seeing in a snappy format. Let me go to here, remove this one. Okay, let's delete this one. Here, go to once again, go to our ETL jar. Okay, let's select this file. Let's delete this file and type permanently delete. Okay, go to here, delete. Go to our ETL job, go to visual interface, go to target, see, snappy format. See, format JSON only, but we selected compression type snappy. Means it compressed in the snappy format. That's why we didn't see actual data. Then select none. Compression format none means actual JSON format. Then click on save. Then run glue job. Once again go to runs. Select latest run. Let's wait a few more seconds. Yeah, let's refresh. You can see it's still running. Let's wait a few more seconds. So now AWS Glue crawler is succeeded. Go to, sorry, not crawler. Our Glue job is succeeded. Go to our S3 location, then refresh, select this file, click on uh, download, go to file location, then right click on this one, open with notepad, then click on this one. You can see previously we selected compress format. That's why we see output in compression format. Uh, Now recent run we selected none. That's why it is stored in actual format. Okay. Yeah. Yeah. Let's continue, team. As part of master AWS Glue, we are discussing different examples. Okay. So in this, we are going to see one example called renaming columns. Renaming columns. Let's say we already having a database database with the table. Okay. We have already uh, having a data, but I want to rename columns. This is usual requirement. So in our target, we have already data uh, with our complete to source data. Later, our client requested us to rename columns. So we use rename columns transformation, rename columns. We have a option called transformation called rename. Using that, we can rename a columns. So let me show a function here. First, we create a data frame from our uh, glue context. Then here we have a column with the column renamed. With the column renamed, we can pass a old column name, we can pass a new column name. Before that, let me open AWS Glue. Let me open AWS Glue. Yeah, I am opening AWS Glue. In this AWS Glue, let's open Glue catalog. In this, let's open a table. So this is employees table. In this employees table, see, column name is employee ID, name, age, department, and salary. Department and salary. Requirement is change this employee ID to EMP ID, name to full name, salary to monthly income. Okay. So to implement this one, first let's open AWS Glue new Visual ETL job. So click on Visual ETL and here create a ETL job. Create a ETL job. Then here give a name. I'm giving name is rename columns ETL dot py. Okay. Next one. Go to job details. Select IAM. Select a IAM role. Then click on save. Go to script. Go to script. Just remove this one. Okay. Uh, Before that, let me open a duplicate tab. Okay. So here my blue database catalog name is Sreenivasa underscore. Let me go to catalog databases. My database name is Sreenivasa underscore DB. Okay, let me rename here. Okay, yeah, take the script, go to your Visual ETL, Visual ETL. So Visual ETL, we select drag and drop, right? Instead, click on script, click on edit script, click on confirm, then select this one, remove, place your script. Observe here, first all imports, all imports. Next one, creating a data frame from blue context, blue context. In blue context, we have a Akkem Sreenivas underscore DB. Table name is employees, employees. We are creating data frame from blue data catalog. This blue data catalog pointed to particular S3 file. Then I am converting blue data frame to PySpark data frame. Then in PySpark data frame, we have a with column renamed, old column name, new column name. Again with column renamed, old column name, new column name. Dot with column renamed, old column name and new column name. Then finally, I am converting PySpark data frame to dynamic data frame. Then I am implementing write dynamic frame. I am saving where? Inside this S3 location. Let's say for all my S3, let me create a S3 folder. So here, let's see, we have created bucket for our glue, Akkem Sreenivas -glue. This is my S3 bucket name. Okay, let me take this bucket name. Let's change this bucket name. Bucket name is this one. Okay, and here also let's change bucket name. Okay. Now let's observe here. Go to AWS script. Then under this bucket, there is a folder called outputs. So it is going to close here. Let me rename this one. Instead of again creating one more, let's say, yeah, let me create a folder called outputs. Under outputs, this is the folder, employee columns renamed. In this, it is going to create a output file format is file format. Here you can see Parquet file format. Then compression type is snappy compression. Okay. Then click on save. Then click on run button. Go to your runs. You can see run is started. It will take a few seconds time to complete your ETL job. Once it is completed, here in S3, you are going to see a folder called outputs. In that outputs, you are going to see a folder called employee columns renamed. Let's wait a few seconds. Here glue job is running. Yes, you can see execution is succeeded. Go to S3 location, refresh S3 bucket. You can see folder called outputs. Under folder, you can see employee columns rename folder. In this, it is generated a Parquet file. Select a Parquet file, and if you want to know column names are renamed or not, select a Parquet file, click on actions and click on, or you can see download. It is downloaded. Let's go this file. Let's open this Parquet format. You may not understand this Parquet file format. Okay. If you want to know records in Parquet format, you can open any online Parquet viewer. Let's say uh, Parquet viewer online. Let's click on any one Parquet viewer. Select a tool, select a file. Let's say under downloads, we have this file. Click on this one. Then you can see record details. Employee underscore ID renamed with employee ID. Name is replaced with full name. And salary is replaced with monthly income. So column names are renamed successfully. Clear, right? How to perform renaming columns using AWS Glue job? Yeah, yeah. Let's start in. Let's continue. Master AWS Glue. In this, we are going to see filter data transformation. This is one of the most usual requirement today. Example, I have a sales data, and in that I want to let's say I want to particular product data. I do not want all products. Then we can use a filter condition. Next one. I want to filter based on salaries. I want to filter based on gender category. I want to filter based on country. I want to filter based on particular city. So filter transformation is usual transformation in ETL jobs. Let's see how we can implement filter transformation. Okay. In our S3, we have employees file. For that, we created a blue catalog table definition, and we have a column called department. Department, I want to filter only IT department records. Let me open previous Parquet viewer. Okay, let me open here. You can see in this Parquet viewer, there is a column department. Here we can see IT department 1, 2, 3, 3. So if I apply this filter operation for IT, final output of Parquet file should contain only IT department data. Okay. So for that one, I am implementing filter data transformation using AWS Glue. Let's go to AWS Glue. Let's go to ETL job. ETL job. Let's click on ETL job. Click on Visual ETL. Then give a job name. Filter ETL job dot py. Then go to job details. Add IAM role. Add IAM role. Then click on Save button. Then go to Script. Click on Edit Script. Click on Confirm. Then remove the script. Just paste the script file in. See here, this is script logic. See here, I am adding the script logic. Only I am adding this logic. Next one, I am going to take remaining part from previous script. Go to Visual ETL and Visual ETL jobs. Go to this rename column. Until data frame creation, this part, just copy from this, just paste here. So from data frame creation, we are writing logic. Okay, see here, we are connecting this database, we are reading this table, and we created a dynamic data frame. And here we are using filter.apply. Filter.apply. We are passing our dynamic data frame name. Here I am writing lambda function. In this lambda function, every row I am checking IT department. So I'm going to create a new data frame with all IT department records. Then finally, I am going to write output into this S3 location. S3 location, employee filtered folder. Okay. Let's click on save button. Let's click on run button. Okay. And then you can see go to runs. Go to runs. You can see run is started. If there are no errors, it is going to finish. Let's wait a few seconds to complete this one. Yeah, job is succeeded, and let's go S3 location and let's go to outputs. Let's refresh. See, uh, employee filtered. Then select this one. Before that, let me delete this old Parquet file. Let me download this latest Parquet file, filtered Parquet file. Once again, go to filtered one. Let's click on edit, or let's say uh, back. Then once again, upload a new file. Select a new file. Then click on upload. Then you can see only IT department records. Let's go another Parquet viewer because you exceeded daily uploads. Go to another Parquet viewer online link. Then click on another Parquet viewer. Let's go other one. Then select upload. Select a Parquet file. Then you can see all IT records. Clear writing? So we got only department IT. Yeah, let's continue master AWS glue. In this, let's discuss a remove duplicates transformation team. Usually, our input source may contain duplicate records. So we may get this usual requirement team. So before persisting this data into target location, using glue, first remove duplicates, and then finally persist output into target. Okay, using AWS glue, we delete all duplicate records, row by row comparison. Let's say we have 1 billion records, or we have multiple records. If we take other technology, it may take long time to process row by row comparison. That's what we are going for this AWS glue to perform fast comparison. So it uses parallel and distributed computing so that it compare row by row. It compare any number of rows parallelly. That's why you are going to get a response very faster. Let's see how we can implement this uh, implementation. Go to AWS Glue. Okay. So go to AWS Glue editor. Go to ETL jobs. Okay. Click on Visual ETL. Then give a title to this one. Let's say remove duplicates ETL job. Remove duplicate ETL job.py. Then go to job details and add IAM role. Then click on save button. Go to script and click on edit the script. Click on confirm. Okay. Just take your program. So first you need to add these transformation details within this job. Okay. See here. Move this import from here to imports location. You can use import anywhere, but recommended use all import as a first. Then here, see, we are connecting this database. We are connecting this employees to table. Employees to table container duplicates. Let's go my input location. Let me go to C drive. Let me go to datasets. Let me go to AWS Glue. Here, let me take one employees2 file. In this employees2 file, we have duplicates. 101 repeated 3 times, 102 repeated 3 times, 103 repeated 2 times, 104 repeated 3 times, 105 repeated 3 times. My requirement is I want to delete all these duplicate records. So first what I am going to do, in S3 location, in my buckets, S3 glue, here under I am creating one folder called employees2, then create a folder. In this folder, I am uploading my file, local file. I am uploading this local file into S3 location. Okay. Then click on close. Go to Glue data catalog. Go to crawler and create a crawler. Then crawler name employees2 underscore crawler. Then click on next button. Add a data source. Select a S3 file location and select this AWS Glue and select employees2 folder. Okay, then click on choose, then click on add data source, click on next button, select a IAM role, then click on next button, then select a database, then click on next button, then click on create a crawler, then click on run crawler, go to crawlers, refresh. You are going to see a new crawler. It is running and it is going to connect your S3 file and identifies column names, identifies data types, and persist that meta information into Glue data catalog. Let's wait to complete this one. Yeah. So crawler is completed, almost completed. Go to AWS Glue, go to uh, tables. You can see table called employees2. Okay. Then go to your script. Okay. Then here we are pointing this table. Now table is existed. Then how we are dropping duplicates? See, in PySpark, we have a drop duplicates transformation. You just give drop duplicates, then it will delete all duplicates. It will compare row by row. If same row is replicated in input file, it will delete. Okay. Then finally, we are writing output into this bucket employee drop duplicates folder with Parquet format with snappy compression. Let me save this program. Let's run this program. Go to runs. Let's wait a few seconds to complete this one. If there are no errors, then it will status become succeeded. Once it is succeeded, then we are going to verify in our glue under glue outputs. Under outputs, it is going to create a folder called employee and hyphen duplicates, removed duplicates with this name. Yeah, let's wait a few more seconds to complete glue job team. Yeah. So observe here, we got error saying syntax error, invalid syntax, line number 7. Go to script and go to line number 7. Go to line number 7 from AWS Glue dynamic frame, import dynamic frame and see what is the error here. Go to runs. So syntax error, invalid syntax. Okay, okay, yeah, yeah. Let me modify this one. Import. Okay, then save this one. Rerun this job. Let me change in our code also. Let's save this one. Let me go to runs. So this pointed failed one. Select running one. You can see running one logs. You can click on logs. You are going to see process of running your Glue job. Click on run details. Click on run details. Let's wait for completing this Glue job. Meanwhile, let's remove this generated file. Yeah, we already removed it. Let's wait a few seconds. Yeah. So job is succeeded. Go to S3 location, refresh. You can see folder called employees hyphen dropped hyphen duplicates. Click on this one. Select this Parquet file. Click on download. Okay. Go to Parquet viewer. Let's try to upload a new file. Click on this one. Then select this file. Click on viewer. Now you can see only original values. Earlier we seen with duplicates, but now you are seeing only unique values. Okay. Clear writing? How to delete a drop duplicates? Yeah. Yeah. Let's continue AWS Glue team. As part of AWS Glue, we are discussing different examples. In this, let's continue joining datasets using join in AWS Glue. So in this, we are going to take a different data sets. One is employee data frame and other one is departments data frame. Let me open data sets. I am going to open datasets folder. Let's say datasets folder. Here AWS Glue. Here I have emp.csv file. Let me open. Okay. emp.csv file. And I am opening another folder department.csv. So these are department file. So if you see, we have 11, 12, 13, 14, 15 departments, and we have different employees. Let's say total 11 employee records. Okay. Yeah. Now what I'm doing, first I'm going to create a tables using AWS Glue crawler. So for that, first I'm going to upload these files in S3 bucket. S3 bucket. Let's say I'm opening AWS S3. S3. In this, we have different buckets. Let's say here, Akkem Sreenivas Glue. In this, I am creating two folders. One folder is EMP, and another folder is DEPT. I am creating another folder DEPT. Okay. Then under EMP folder, place EMP file. EMP file. Click on upload. Click on this one. Click on close. Under DEPT, upload department folder. Okay. Click on upload. Then create a Glue crawler. So go to data catalog and click on crawlers. I'm opening a new tab. So create a crawler. EMP underscore crawler. Then click on next button, add a data source, and I'm selecting S3 file. Under Glue, we have EMP folder. Select this one and click on add data source. Click on next button and select IAM role. Then click on next button. Click on database and then click on next button. And then click on create crawler and run crawler. Similar way, create another crawler. Let's say go to crawlers, create crawler and DEPT crawler, DEPT underscore crawler. And then click on next button, click on add data source, select a file, select a folder, and then select DEPT folder. Then click on add S3 source, click on next button, then select IAM role, then click on next button, select a database, and then click on next button, then click on create crawler, and then run crawler. Okay, then go to crawlers, refresh this crawlers. Okay, DEPT crawler is running and EMP crawler is succeeded. Meanwhile, go to AWS Glue and create a job ETL job, then give a job name Job name is join datasets dot py or join datasets ETL job, join datasets ETL job dot py. Then go to job details and provide IAM role. Then click on save button and go to script file. Okay. Click on edit script. Click on confirm. Then go to end of this commit, between this commit. Okay. Let's take our code and here select these parameters, these properties. Observe here what kind of join operations we are performing. Let's see here. So first I am creating a data frame for employee data frame by pointing employee table in Akkem Sreenivas underscore DB. We have EMP table. So creating dynamic data frame from data catalog, created EMP data frame, converted into Spark data frame. Next one, created DEPT data frame by pointing blue data catalog, then converted into Spark data frame. Okay, now I am performing inner join, inner join, inner join, employee df dot join DEPT df on department number. Tell me, what is inner join? What is inner join? Okay, we can take this one as separate. Let's take this one. Yeah, tell me, what happens here? Department number and department number. So here 11, here we have 11. So total 4 records in EMP table of department 11 and 1 record in department table. So we get how many records here? We get 101, 101 Sreenivas 20,000 and male 11 IT Dev Hyderabad. So we are joining two tables, by using join condition called inner join, and we will get match records from both the tables, right? So we get in this way. One record is matched and another record is matched and another record is matched and this one also matched, right? So in this way we get details. Next one, another record is 12. 12 is matched. 12 is matched. Let's say instead of take this one, different color. 12 is matched. 12 is matched. Next one, 13. 13 is matched. Matched record. Next one, 12 also, sorry. So we have 12 again, 12 again. Next one, let's take 13th department, 13th department, 13th department, and 13th department. Next one, 14th department. Let's say there is no 14th department. So this will not come. Yes or no? So here we have 15th department. There is no 15th department in EMP table. In here we have 16th department. There is no 16th department table. Only 11, 12 in department data we will get. The giant means only matched records from the both tables, right? Handwriting. Okay. Next one. Next one we are implementing. Next one we are implementing left join. Left join. So first all match records from both tables. All match records from both tables. Left join. So left join. Left join. Match records. Match records. Match records. All match records. 13, 13, 11, 12, 13. Okay. All match records. Next one. Yes, yes. EMP2 to DEPT. Observe the code. So we are doing left to giant, left to giant, EMP.df, left to giant to DEPT. Next one, non-matched record of left table called this one, 16th. You will not get 15th, 14th and 15th, but you will get this 16th. But EMP department, we get empty records. Sorry, department, we get empty records. Yes, sir. All matched records of both table, non-matched record left table called EMP with empty records, empty columns of DEPT table for that non-matched record. Next one, right join. If we use right join, then tell me, right join means first one, all matched records from both the tables. 11, 12, 13, 11, 12, 12, 13. All matched records. Next one, non-matched records from right side table. Right side table. For these two rows, we get left side table empty values. Empty values. Yes or no? For these non-matched records from right side table, we will get, but values of right table is empty because there is no values matched to right side table. If we use full outer join, what happens? First one inner join, next one right join, next one left join. Both these three combination output we will get in full outer join. All match records from both the tables, non-match records from left table, non-match records from right table. All the values. Okay, so we implemented this data set using here. So left to join, right to join, and first one inner join, next one left to join, right to join, and full outer join. Let me see here. Here, Akkem Sreenivas -glue. In this output folder, it is going to create a output files. Let's take save this one and then click on run button. Click on run button, then go to runs and it is started. Let's wait a few seconds to complete this program. Here we got error. Dynamic frame is not defined. Okay, let me go here. I did not import this dynamic data frame team. So it's a mistake of import because I used imports from that one. That's why we got this error. Let me go script. Let's import all this. Then click on save and rerun. Go to runs. Select this run. So job is success. Go to S3 location and go to glue job. Then refresh. Go to outputs. Outputs. You can see. You can see. Line underscore inner. Okay. Next, go to here and join underscore left, join underscore right, and join underscore full. Let's first see join underscore inner. Let's download this file. Okay, open this file in any one of Parquet viewer. Parquet viewer online. Let's take this one. Let's take third one and select the file and go to downloads. Go to here downloads. Sorry, I saved in the form of CSV only. That's why uh, we are not able to see Parquet file. I saved in the format of CSV only. See, 12, 11, and 13. All match records. Next one. Next one. Let's see. Left to join. Go to left to join. Select this file. Download. Go to downloads. Open this file. See, match records 12, 11, and non-match record from EMP table. For department, there are no match records. Yes or no? Next one. Uh, Coming to right to join. Let's open right to join output. Right join. Download. Go to folder location. Let's open this file. See. So match records from both the tables. Okay. Both the tables. Non-match records of right side table, but no record matched in EMP table. No match records found in EMP table. Clear, right? Yeah. Yeah. Let's continue. In this session, we are going to see aggregate data using aggregate operations in AWS Glue as part of master AWS Glue. Let's continue another example, aggregating data using aggregate operations in AWS Glue team. Okay, so here we have DB. In this DB, we have employees table, and in this employee table, we are going to perform aggregate operations like total salary, sum, average, min, and max, and next one count. So we have 5 aggregate operations in SQL: count, sum, average, and min, and max. Okay, department wise, I want to perform department wise count, department wise salary, sum of salary, department wise average salary, department wise minimum salary, department wise maximum salary. Each department I want to count how many employees and what is total salary, what is average salary, what is the minimum salary in department, what is the maximum salary in department. Later, I may take decisions based on this output. Okay, let's start implementing this one tip, aggregate operations. So go to AWS Glue. First, log in as a root user in AWS Glue and open your Glue. Then click on ETL jobs. Then create a ETL job. Before that, let me see here. Select a region North Virginia because we created all Glue jobs in North Virginia. Okay, go to ETL jobs. You can see all ETL jobs. Now, let's create a ETL job. Then here, write your ETL job. So my ETL job name is aggregate data ETL. Aggregate data ETL job.py. So let's create a job. Now go to job details and assign a IAM role. Then click on save. Now go to script file. Then click on edit script. Yes, I want to edit the script. Then add your ETL job between the job commit. Okay, let me go to our code. So take this code. Yeah, let me take this entire code. Sometimes we may miss dynamic data frame. Instead, let's take this entire code. Let's add this entire code. See, first I'm creating data frame. First I'm creating a data frame to point to this employees table. We have created a crawler to crawl employee file in Glue data catalog, right? Then I am pointing this Glue data catalog. I am creating a data frame, okay, Glue data frame, and I am converting it as a Spark data frame. Then I am applying group by operation. I am passing one column. Let's say I have four groups. Four groups. It will create four departments. It will create a four groups. Four groups. And let's say this one is 11th and 12th and 13th, 13th and 14th. 14th. Okay. And here all 11th department records, all 12th department records, all 13th department records, all 14th department records. 14th department records. Okay. Now, so this group by function of Spark creates records in this way. Then in this we have aggregate function. In this aggregate function, we can pass value count operation and which column you want to perform count. So I'm saying here there is a column called employee ID. Take that employee ID as a parameter, then count records. So it will return, let's say 10 records, 5 records, and let's say 20 records. Assume this one is 15 records. Assume. In this way, we have records. Next one, it will call average, and here we are passing salary column as input. Then it will take salary column, performs sum. Let's say all is file 2 lakh or 3 lakh, 3L and 2L. Let's say this one is 30L, this one is 20L. Like this, it will perform count. And then we are passing salary column as input to average function. Then we are asking to perform average. So here 3L by 10, you will get average. 5L by 3, you will get average. And 30L by 20, you will get average. So in this way, it will perform min value, max value, and additionally, see, we are using alias, alias, alias. For this result, for this result, column name, we are giving total salary, average salary, employee count, min salary, max salary. Alias function we are giving. Result we are creating one column. In that column we are storing result. Okay. And finally, we are converting our PySpark data frame to dynamic data frame. And finally, coalesce function we are using. Let me add one important point why I am adding coalesce function. Let me say, let me understand. I created data frame from file which is presented in S3, S3, S3. Then I created a data frame. I created a data frame. Assume this data frame created with three partitions, three partitions, three partitions. Assume it created with three partitions. So when I write this one, when I write this one, uh, in output path, in output path, in this location, what I'm doing, write dynamic data frame function I'm using, write dynamic data frame. So I'm saving into output location where I'm storing in sorry, in this output location. So my data frame having three partitions, right? It is going to create a three output files. In this output location, it will create a three output files. So I do not want to three output files. I want a single file. So we have repartition. There are two functions, repartition, repartition, and you can specify number of partitions and coalesce. You can use coalesce function or repartition function. Coalesce compared to repartition, coalesce is reduces lot of transformations in the background. It improves performance compared to repartition. You can use either repartition or coalesce to reduce number of partitions. Then finally, I'm saying I want only one partition. Combine all three partitions into one partition. So in output location, I will see only one file. Okay. Let me save this program. Save this program. Let me open S3 in another tab. Under AW Akkem Sreenivas glue. Here we have outputs folder. Outputs folder. In this outputs folder, you are going to see aggregate. What is the name? Uh, Name is aggregate. Aggregate output. Okay, let's click on run. Let's go to runs. Let's wait for a few seconds to complete this job. Let's wait a few seconds. Almost completed. Let's wait a few more seconds. Yeah, it is succeeded team. Let's go to S3 location. S3 location. Let's refresh. You can see aggregate output. In this, you can see the file. Let's click on this file. Let's click on download, and which format we uh, persisted this file. Go to script. We saved file in CSV format. Let's go to downloads location. Open a file. Okay. Let's open this file. Let's say notepad. See, each department wise count. HR department count is 3. And total salary, average salary, min salary, max salary. Department count, total salary, average salary, min salary, max salary. IT department, total count, total salary, average salary, min salary, max salary. Clear writing? Yeah. Now let's continue master AWS Blue different example stream. In this, let's start discussing pivoting data in AWS Glue. Pivoting data in AWS Glue team. Let's see input and how we are going to pivot. So this is my input data team. Input data. If you see, I have a 12 records in this input file. My requirement. See here we have a column called year. We have a column called year, and we have departments, and we have employee ID and employee name and year. So if you see year, if you see 2022, how many times repeated? 1, 2, 3, 4, 5, 6, and 2023 repeated in 1, 2, 3, 4, 5, and 6. So my requirement here, I have a 12 records, but I want to convert this 12 rows based on the year. If year I have 4 different years, I want 4 rows. If year only 2 years, then I want only 2 years. I want to convert based on the year column, the value presented in year column. Okay. So converting multiple rows into few rows based on particular column value. Based on the column value. If you want to convert your number of rows, then we use pivot function, pivot functionality. There is a function called pivot, and we pass column name. Sorry, we pass what? This one, group by year, pivot based on the department. See here, if you see department, see department values converted into columns. one important note to do. One important note. We have rows. We have rows. We have rows. In this rows, we have a column called department. Department. Whatever the column, it may be year, it may be column. It may be year column, it may be department column. In this column, we have values. In this column, we have values. V1, V2, V2, and again V1 and V4 or V3, and again V2. So total we have multiple values. I want to convert this as a column name. New column name. V1, V2, V3. So for this one, if you want to convert a row into a column value, a row value, you want to convert it as a column, then we are using pivot. Convert rows to column. Convert rows to column. We use pivot function. Let me implement this one. Pivot data ETL job.py. Then go to AWS Glue. Okay. Go to ETL jobs and create ETL job. Then give a name. Go to job details. Add IAM role. Then click on save button. Click on script. Edit a script. Take your this code. Okay. Then see, I am connecting employee salaries. Okay. So go to input location. Go to C drive. Go to datasets. Here, go to AWS Glue. In this, you can see employee salaries .csv file. Open this CSV file. Okay, you can see the CSV file. Okay, let me create a table for this one. So our requirement is I want to create EMP salaries. So first, what I'm doing, I'm opening new tab, duplicate tab. Then go to this one. Go to crawler, data catalog. Go to crawlers. Okay, and create a crawler. Give a crawler name, employees salary, employees underscore salaries underscore crawler. Then click on next button. Then add a data source. Before that, you need a data source. Go to AWS Glue and create a folder. Folder name employee salaries. Then click on create folder and go to employee salaries. Upload this file. Employee salaries file. Then click on upload. Click on close. Click on close. You can see employee salary. Go to crawler. Then add a data source. Select a file path. Go to AWS Glue and go to select employee salaries folder. Click on choose. Okay. click on add S3 data source, click on next button, select IAM role, then click on next button, choose database, then click on next button and click on create crawler. Okay, so crawler is created successfully. Then run crawler. Okay, go to crawlers, refresh. So employee underscore salaries underscore crawler is creating. Let's wait a few seconds to complete. Yeah, it is completed. Go to our script file, then save the script file, run the script file, go to runs and click on run button. Let's wait a few seconds to complete this chapter. Job is succeeded to. Let's go to S3 location. Let's go to AWS glue bucket. Go to outputs folder and you can check pivot, pivoted underscore salary and see what is the output format. Go to script and see output format is CSV and go to S3 location, select the file, download the file, then open a folder, open a folder. Let's open this folder. See here, finance department and sum of salary, HR department, sum of salary, IT department, sum of salary, group by year, each year wise. Clear, right?